Okay, ladies and gentlemen, I think that we'll try and start our afternoon session. I'm Fiona Fordyce from the British Geological Survey, and I'm also going to be chairing myself for this session, which is dealing with the urban geochemistry in its wider context. So we're really touching upon issues such as soil sediment and surface water quality in this session, and it's really sort of focusing on the chemical quality of the surface environment. Now, chemical elements occur all around us, they're everywhere, we're all made of them, but of these naturally occurring elements, approximately 26 are essential to plant, animal and human health in small doses, but they are harmful in excess. And those are the elements shown in green on the periodic table there. And then we have the elements that are just plain bad for us, the ones in red. And then also of concern are man-made potentially harmful substances such as organic pollutants like PHs and PCBs. And so it's important that we have an understanding of where these things are in the environment, and that's really what this session is going to address. Because whether they're from natural sources such as rocks or from man-made sources like urban areas, industry and mining, they get dispersed into soil, water and air, and through various pathways like uptake into plants, crops and animals into the food chain, they end up in us human beings. And so we need to know where these things are from 2 points of view. On the one hand, in terms of deficiency, making sure that land is providing enough of the essential nutrients for crop and animal health for agriculture. But on the other hand, we don't want to be exposed to too much of these potentially harmful things in the environment, and so that tends to be dealt with under environmental legislation. And for example, for water quality, that's dealt with under the EU Water Framework Directive, and for soil quality here in the UK, that's largely dealt with under our Environmental Protection Act, and we have contaminated land exposure assessment guidance to help assess the risks to human health from soils. Now, urban areas are one of the main sources of these substances in the environment, and so this session is going to be presenting work looking at the urban and anthropogenic impacts in the Clyde Basin that's been carried out recently. And I'm going to start by talking about a work that BGS has been doing to carry out geochemical surveys of the Glasgow and Clyde Basin area. And I'll just give an overview of these surveys and then talk more particularly about some of the soil work. And so here in the UK, our National Strategic Geochemical Survey is called the Geochemical Baseline Survey of the Environment, GBASE. It's based on the collection of stream sediment, stream water and soil samples. And back in the 1990s, we started collecting soils in urban areas, and to date we've surveyed about 27 cities, including Glasgow. And the Glasgow and Clyde Basin study was carried out under the CUSP project that you've been hearing about today, in collaboration with local authorities, particularly Glasgow City Council. And the work was carried out in 3 main phases. The first phase, looking at rural stream sediments, was done in the 1980s, so that actually predates the CUSP project. But the CUSP work has really focused on looking at the urban environment of Glasgow City itself in the early 2000s in terms of soil and stream quality, and then the final phase of work that we've been doing more recently, looking at rural and urban stream water and soils in the rest of the Clyde Basin. And so just to give you a bit of an overview of the characteristics of the Clyde Basin that might affect the geochemistry, it extends from the River Clyde in the north, where we are now, if I can find the pointer on here, which maybe can't, oh yes, there it is, right down to the Lowther Hills in the southern uplands in the Scottish borders. And upland areas sort of predominate around the edge of the area and in the south of the area, and these are really characterised by peaty heather moorlands shown in the purple and yellow colours on the map there, with some forestry shown in the dark green colours. And then in the centre of the area, in light green, we have the main agricultural areas, and that's largely arable land. But the urban areas are really focused in the Glasgow conurbation, centred on the River Clyde here in the north of the basin. And as we've heard, Scotland's largest city is here in Glasgow, and it was a major industrial powerhouse in the 18th to 20th centuries. But as that heavy industry has declined, it's left a legacy of pollution. And in terms of the geology of the area down in the south, here in the purple colours we have Silurian and Ordovician greywacke rocks, and then we have Silurian age, Devonian age volcanic rocks, here shown in yellow in the south of the area, and then we have younger carboniferous volcanic rocks up up around Glasgow, shown in pink, that Alison was talking about earlier this morning. And then the Devonian sandstones in the centre and north of the area shown in red. But the main bulk of the area is underlain by Carboniferous age sediments shown in the blue, brown and grey colours there, that are sequences of sandstones, limestones and coals, as we've heard this morning. And the coal was the real driving force behind the industrial development of Glasgow. So these are some of the factors that may influence the geochemistry. And as a result of the surveys that we've carried out, I just wanted to give you an overview of the data sets that we now have for the Clyde Basin. And so we have a fairly extensive data set of stream sediment and stream water samples, which I'm not going to talk about because my colleague Sylvia Lass-Evans talked about the sediments yesterday, and my colleague Jenny Bearcock is going to talk this afternoon about the water samples. What I'm going to talk about are the soil samples, which have been carried out in soil sample surveys, which have been carried out in a series of stages, and as well as the systematic surveys of the urban and the rural areas that we've done. I'll just briefly mention that in 2011, we also collected a set of samples from particular land use types in the Glasgow city area for future studies that we hope to look at organic pollutants in the soils as well. And those are the samples shown in black in the main area of Glasgow. Now the soils are based, the soil sampling is based on a systematic grid, so we collect 4 samples every kilometre in the urban area and 1 per 2 kilometres in the rural environment. And they're all collected using a hand auger from the centre and corners of a 20-metre square, and we collect the samples to 2 depths. The samples are analysed by XRF for about 50 chemical elements, and we also determine the pH and then the loss on ignition, LOI, as an indicator of the organic matter in the soils. And we've also measured the depth of the organic rich layer in the soils. But actually the deeper soils are generally not analysed. We tend to just store them. And so the data that we have really refer to topsoils. And so what does this tell us about the soil quality across the Clyde Basin? Well, if we take the element chromium as an example, then we can very clearly see the geological and the urban influences. And so in the geological sense, then, the high chromium values which are shown in red are found with the volcanic rocks in the Clyde Plateau Volcanic Formation, and down here in the south of the basin. But over the Clyde Plateau volcanics, it's not systematically high because these volcanics comprise a variety of different rock types, and as the lavas have evolved in their composition, the further north you go, then we get lower chromium values in the rocks, which is reflected in the soils. But what's also going on here is that the upland areas formed by these volcanic rocks are where you get the very peaty organic rich soils, and the organic rich soils have lower concentrations of chromium. So that's a rather mixed signature that we're getting across the Clyde Plateau volcanics. But we can also see the influence of man, because in the urban area then the chromium concentrations in the soil are generally elevated, and then within that we can see particular anomalous high values. And so, for example, there's a very clear one which corresponds to the Ravenscraig site in Motherwell, which was the largest steel mill in Europe until it closed in 1992. And similarly, the former iron pit at Calderbank and the Moffat Mills paper mill and distillery area in Airdrie, they come out with very high concentrations of chromium in the soil. And then right across the south of central Glasgow, we get very high concentrations of chromium there also. And that reflects the fact that Rutherglen in southeast Glasgow was home to the world's largest chrome processing works until the 1960s. And John Farmer is going to tell us a lot more about that this afternoon. And then we also have high values associated with made ground in Hamilton and Renfrew and Milngavie as well. And so in fact what the data show is that 20% of the urban soils and 11% of the rural soils exceed the UK soil guideline values for human health. But as John will explain later, there's a big difference between the natural rural type of chromium and the industrial type of chromium that we find in the urban environment. In contrast, if we look at an element like selenium, its distribution is very much influenced by the organic matter content of the soils. And so here on the right is a map showing the loss and ignition, which is the measure of the organic matter content, and you can see that all the high values correspond to the upland peaty areas around the edge of the Clyde Basin. And on the left, if you look at the distribution of selenium, the high values very much mirror that distribution in the organic soils. And that really reflects the atmospheric deposition of selenium into these peaty soils, and these peaty soils trap the selenium there. But we do also see some elevated values in the urban environment as well. Some of those are associated with discrete sources, such as the clay and coal mines at Newmains in Wishaw. Ravenscraig comes up with a small anomaly again. We can see the Rutherglen metal processing area, and also the Clydebank shipbuilding area comes up with slightly higher values, which is just across the river from where we are now. But in fact, none of the soils exceed the soil guideline value for selenium in the soils. And if we sort of flip to talk about the other side of the argument and look at things in terms of deficiency, then in fact the soils in the blue areas in the upper Clyde Valley and up around Dumbarton in the north of the area that are developed over the Devonian and Carboniferous sandstones, they are actually low in selenium in terms of providing adequate selenium concentrations to grazing animals for their health. Moving on to look at another element, lead, which shows a different picture because it's very much influenced by mineralization and urban influences. And the thing that really stands out in the map is that big red blob in the south of the area, and that corresponds to the former mining area at Lead Hills. And as a result of the lead ore extraction that went on there, then the lead has been dispersed in the environment. Lead is also relatively high in the organic rich soils that you can see in the hills to the north and west of Glasgow, again because of organic matter trapping lead from the atmosphere. But then we also see elevated levels in the urban environment. And some of those correspond to discrete areas such as the Ravenscraig steel mill again. But actually what we really see with lead is that it's the city centres of all these areas that really come out as being high in lead concentration. And that's a result of traffic fumes from the former use of lead in petrol, from lead in coal burning, and lead that used to be used in things like paint and so on in the past. And it all ends up in the urban soil environment. And in fact, about 6% of urban soils and only 1% of rural soils exceed the guideline values that we have here in the UK. And so on the basis of the initial studies that we've done on the impact of the urban area on soil quality, what we found is that regardless of the geological parent material, many metals, especially calcium, copper, lead, antimony and tin, are 2 to 3 times elevated in the Glasgow urban soils versus the rural soils. And this is actually a typical indicator suite of urban pollution that's found in other cities also. And the calcium is high because of made ground and the amount of building rubble and cement, which is calcareous material, that ends up in urban soils. And so if we take nickel as an example shown in the graph there, then the graph shows the ranging concentrations across different rock types in the area. And the rural soils in pale purple are generally lower in concentration than the urban soils shown in darker purple, right across the board, regardless of the geology. But the geology is still important because if we look at the Devonian sandstones, their natural concentrations in the soil are lower, and so the urban concentrations are also lower. And this is just a good example of the fact that urban soil quality is a combination of the natural and the anthropogenic inputs. But basically what the data show is that even 40 years after the major industrial decline here in Glasgow, then the legacy of urban and industrial pollution remains. Now the soil data is going to have a wide range of applications, and I'm not going to talk about all of those, and I haven't listed them all here. But I'll just point to a few. The depth of the organic rich layer in soils work that we've done, my colleague Paul Everett has a poster outside if you'd like to learn a bit more about that. And then the other uses and applications of the data in terms of uptake of metals from soils and looking at links to human health are going to form the basis of some of the talks this afternoon. But one thing that I did want to mention is that we have been working with the hydrogeologists to try and develop a GIS tool that assesses the threats to shallow groundwater quality from the metals pollutants in the soil leaching down to the groundwater. And it's a citywide first-pass traffic light screening tool. And it's based on a BSISO leaching potential method, and we've basically combined that with our known soil metal concentrations from the GBase dataset. And of all the sort of parameters that you input into this model, the main controls on the areas that are predicted to be most at risk seem to be the shallow groundwater depths and the high soil metal concentrations. But what doing this work flagged up was the lack of systematic groundwater information in Glasgow, and that has fed into the ASK network that Helen talked about this morning, and the groundwater monitoring work that you're going to hear about later on this afternoon. Now, there will be many outputs from the soil survey work in Glasgow, but in terms of the main outputs, the initial report on the Glasgow soils has already been published, and we are working on producing a geochemical atlas for the Clyde Basin that's going to document the soil chemistry in the area. And this plus the data set is really being done with a view to providing a basis and a reference for policy and planning and research in the future. I would just like to finish by thanking all the student volunteers who helped carry out all this sampling in the survey area, and the local authorities in the Clyde Basin for their cooperation, particularly Glasgow City Council. Thank you. Okay, I think we've got time for a couple of questions. Yes, Simon. I haven't actually had a chance to look at those in detail because we've been frantically trying to pull these data sets together for this conference. So I'm afraid that I will have to get back to you on that. But we haven't actually done the breakdown yet of looking at the different land uses to see how they stack up. But we will have a look and let you know. Was there someone else here who had a question? Alan. Yes, not surprisingly, Glasgow comes out as having the highest chromium concentrations of any of the UK cities that we've looked at, and Swansea, which was also a big centre of metal processing, came out as second. But for some of the other elements like arsenic and lead and so on, then Glasgow's actually pretty middling in terms of some of the other UK cities that we've sampled. But cities do vary, and cities like York and Lincoln and so on that haven't had a lot of industrial development, their concentrations of chemical elements can tend to be quite much lower and quite closely related to the geological background, even though they are still urban areas. So they are a real mixed bag depending on the history. And Glasgow is a particularly industrialised and complex one to be looking at.
Fiona, John Redshaw from CEPA, just thinking about this issue generally, how is this picture likely to change over time? Clearly we're going back 40 years, as you mentioned.
Yeah.
Are we likely to be in the same situation in another 40 or 100 years' time, or will the situation change?
I think it largely depends what's done with the regeneration programmes that go on. I've just been talking to some people in the audience about that at lunchtime. Because even though that you identify, you've got this package of contaminated land, and the question is, what do you do with it? And is it the best thing to try and dig it all out and remove it? And possibly not, because then you send it all up into the atmosphere as you're doing that, and then you're left with this big bunch of stuff that counts as contaminated material, and you have to go and bury it somewhere else. And so a lot of the work that's being done is maybe sort of in situ remediation programs. And so if you went back after somewhere has been remediated and looked at just the topsoils, then you maybe find that they have much lower concentrations because fresh, clean topsoil has been brought in from somewhere else. But if you went down deeper, you may find that those contaminants are still present in the deeper soil. So it really depends, how much redevelopment and how much regeneration has been carried on.
Just following on from that very briefly, naturally the situation is not likely to change very much very quickly. There has to actually intervene some form of
Yeah.
regeneration.
Yeah. Yeah. Yes?
So what was the depth of soil sampling?
We take two depths. We take, basically we just scrape off all the grass and stuff at the top, and we take the sample immediately under that, and we classify that as 5 to 20 centimetres. And then we go down and take one at 35 to 50 centimetres. But we don't generally analyse the deeper soil samples, so we don't have deep soil information for the whole of the Clyde Basin. We have it for Glasgow, but not for the whole of the Clyde Basin. We do it subjectively as we're collecting the samples. We measure whether it's assess whether it's a clay or a sandy soil, but we don't actually make laboratory measurements of the particle size. Okay, have we got to move on? I think we've got to move on. Sorry. Have I got time for one more? Yep. One more quick one. Sorry.
You've been looking at the elements, and someone looking into, let's say, organic contaminants for chlorinated hydrocarbons.
Yeah, sorry, I'll come back to the microphone. Yes, this Opus soil survey that we did in Glasgow City on particular land uses, we are going to be looking at organic contaminants, but we don't have the resources to analyse them routinely on all these samples because it's very expensive.